Welcome back, and we are on chapter 5, section 5.7, factoring by special products. This is a review to allow us to go through chapter 6, rational expressions, where we're going to apply a lot of factoring to simplify and solve problems. The first objective is going to be factor a perfect square trinomial. And a trinomial that is the square of a binomial is called a perfect square trinomial. Let's have a look at how it looks like. It kind of looks like this. If you have a square plus 2ab plus 2ab plus b squared equals a plus b squared. And on the other hand, if you have a squared minus 2ab plus b squared, this is going to be a minus b squared. Let's work this first example, and we have here x squared plus 12x plus 36, and the question asks to factor it. And we have to compare with the perfect square trinomial that we have seen before, and we need to have a squared plus 2ab plus b squared to be able to make it to write it as a plus b squared, right? If we have this form, then we can do the factoring. Comparing to have a squared, x is going to be the a, so x squared. And then you need to have 2 times 12 divided by 2, 6. 2 times 6, 12. Times x plus, and then this is going to be b, right? This is going to be b, which is squared is going to be 36. And actually we can confirm this is in the right form to be factored, and we can rewrite it as x plus 6 squared. This example, we have 16x squared minus 8xy plus y squared. So we need to compare with a squared minus 2ab plus b squared to be able to rewrite it and factor it out as a minus b squared, right? So let's compare. And here we have 16x squared. Actually, you can rewrite, because 16 is 4 squared, you can rewrite as 4a squared. 4x, I mean, 4x squared. Sorry, 4x squared. And this is going to be our a. Minus 2 times a is going to be 4x times negative 2 times 4, 8x, and now we have here a y plus, and this is our b, right? So we have y squared. So it's the same thing, right? The same thing as this first original expression, and that means we can rewrite it as 4x minus y squared. Right, this is the way we factor the original expression. Next example. Now we have 4m to the 4th minus 4m squared plus 1. And we have to compare and try to identify the terms here. A squared minus 2ab plus b squared. Let's try to identify. Right, 4 is 2 squared. We can rewrite this first term here as 2m squared, right? This is going to be equal to 4m to the fourth. So this is going to be our a. This is going to be our a. Minus 2 times a, 2m squared, times b. And then we have here, if this is b squared, b is going to be 1. And if our b is 1, b squared is 1. And check it out, it's the same thing that we have here in the original equation, right? This is a, this is b squared, this is b, and we can rewrite as a, 2m squared, minus b, 1 squared. In the next example, factor 25x squared plus 50x plus 9. So this we have to identify and make it as a squared plus 2ab plus b squared to be able to factor as a plus b squared, right? And we can rewrite this first term here as 5x squared, 25x squared, right? It's the same thing, plus 2 times, this is going to be our a, 5x, and our b, if this is going to be b squared, our b needs to be 3. b needs to be 3. Plus b squared 9. But this is going to be a problem because now the expression is 5x squared plus 2 times 5, 10 times 3, 30x plus 9. It's different from the original one, right? It's different. We can write this expression here. We can write this expression as 5x plus 3 squared, but this is not going to be equal to the original expression. So this original expression here we cannot factor as a special perfect square trinomial. And let's try one more example. And now we have 16x squared minus 8xy plus y squared. And we have to rewrite this and make it look like a squared minus 2ab plus b squared to be able to factor as a minus b squared, right? And first, let's rewrite this. It's going to be 4x squared minus 2 times, this is going to be our a, so 4x times, and if this is b squared, b equals to y, right? Let's rewrite here, let's put here b equals to y plus y squared. So compare this with the original expression. We have here 4x squared, it is 16x. If you do the square here, if you calculate the square here, it's going to be equal to this 16x squared, right? Minus 2 times 4, negative 8xy, negative 8xy, okay? Plus y squared, and we can write this as 4x minus y squared. This is going to be equal to the original expression. Great! Now I think we're ready to move on to the next objective. Factor the difference of two squares. And let's see what this means. Binomial is the difference of two squares if both terms are squares and the signs of the terms are different. Let's see some examples here. 9x squared minus 25y squared, both are square and the signs are different. Negative c 4 to the fourth plus d to the fourth. Both are c squared is squared and d squared is squared, and with different signs. So both we can rewrite, we can factor out using difference of two squares. And it's gonna look like this. This is the formula. This is what we will remember and compare when using difference of two squares. A squared minus b squared is going to be equal to a plus b times a minus b. Example. Let's work out this example here and let's compare. This one is going to be, let's compare with a squared minus b squared. So we can call x our a, right? X squared. And 9 is going to be 3 squared. So b is going to be 3, right? Therefore, we can rewrite this as x minus 3 times x plus 3. This is equal to the original equation. This is how we factor out this original equation, the original expression. Another example we have here now, 4x minus 1. Factor out 4x minus 1. And let's compare with a squared minus b squared. So a is going to be 2x squared, a is 2x, right? And b is 1 squared. And that we can rewrite as 2x minus 1 times 2x plus 1. Again, just to remember, this is equal to the original expression. This is how we factor out the original expression. Another example, and compare with a squared minus b squared. Okay, so now our a is going to be y squared, and our b is going to be, look here, 16 is 4 squared, and 25 is 5 squared. So we can rewrite this like the fraction 4 over 5. Inside parentheses, everything is squared. That means we can factor out, we can represent as y minus 4 over 5 times y plus 4 over 5. This is equivalent, is equal to the original expression. One more example, 36a squared minus 49b squared. And let's use different a's because I have an a and b here. Let's use different a. A squared minus b squared. And we can rewrite as a minus b, a plus b. Now this a here is going to be 36 is 6 squared, right? 6a. And the next one, 49b. We know that 49 is 7 squared, so I can rewrite as 7b squared. That means we can actually factor it out as 6a minus 7b multiplied by 6a plus 7b. Repeating, but just to make it clear, this is equivalent to the original expression, is how we factor out the original expression. One more example here, and now we have 4x cubed minus 49x. And what do you think about this example? And actually there's something that we can do is not equal to a squared minus b squared, right? Because you have an x cubed here and you have an x here that's not squared. But there's something you can do. Check it out. If we factor x out, let's factor x, and this expression here is equal to x times 4x squared minus 49. Now we can compare what's inside the parentheses, this expression here inside parentheses, with a squared minus b squared. Actually, we can rewrite only what's inside the parentheses. We can rewrite as 2x squared minus 7 squared. That means we can factor it out as 2x minus 7 multiplied by 2x plus 7. What's here inside the parentheses, okay? To represent the original expression, we need to also multiply everything by x. So let's do it here. 4x cubed minus 49x. We can factor it out as x times 2x minus 7 times 2x plus 7. Okay? This is equal to the original equation. The original expression, original expression, that one. Another example, let's try this. Compare with a squared minus b squared, and that one is kind of easy because we know that 49 is 7 squared minus x squared, and that we can rewrite as 7 minus x times 7 plus x, like this. Again, remember, this is equal to the original. This is how I factor it out. What about this one? It's a little bit different, this example, because now we have the parentheses here, but actually we can call all this inside the parentheses as our a, and here it's like x plus 1 squared, this is our a, minus 3 squared, and this is going to be our b. We can rewrite 8 as x plus 1 plus b times x plus 1 minus b. And that's kind of interesting because we still can simplify, right? We still can simplify. This is going to be equal to x plus 4 times x minus 2. This expression is equivalent to the original one, and is how we factor out the original expression. And now, third objective, now factor the sum of or difference of two cubes. This is the formula or the form of the way we factor the sum or difference of two cubes. If we have the sum a cubed plus b cubed, we can rewrite as parentheses a plus b close parenthesis, and open another parenthesis, a squared minus ab plus b squared, close the second parenthesis. And if we have a cubed minus b cubed, then it is going to be equal to parenthesis a minus b, close parenthesis, open parenthesis again, a squared plus ab plus b squared, close parenthesis again. So this is what you need to remember. You need to compare to factor out sum or difference of two cubes. First example, and we have here x cubed plus 1. And every time we have 1 is a special number that you can always rewrite as 1 cubed or 1 squared or 1 to the fourth. Is always going to be 1, and always is something that we can do. And that means we can rewrite this. This is our a cubed, this is our b cubed, so we can rewrite, check the formula, a plus b, x plus 1, times a squared minus ab, x times 1, plus b squared 1. And remembering that this expression here, this expression here is equal to the original one, is how we factor out using sum or difference of two cubes. Let's try another example. Y cubed minus 64. Now we have, let's compare a cubed minus b cubed. So y cubed, 64 can rewrite as 4 cubed, right? 4 times 4, 16, times 4, 64. That means we can factor it out as y minus 4 multiplied by y squared plus 4y plus 4 squared, 16. Those are equivalent. This is equivalent to the original expression. One more example, and 64y cubed plus 1. We know we can rewrite this, right? Okay, can rewrite, because you know 64 is 4 cubed, and you can rewrite as 4y cubed plus 1, and this one we can write as 1 cubed. 1 is a special number. This can be factored as 4y plus 1 times 4 squared, that means 16, 4 squared 16, plus, minus, because this is plus, minus, ab, 4y times 1, 4y, plus b squared, 1 squared, which is 1. I know I'm repeating this, and it sounds a bit annoying, but you have to remember this, that we're doing is factoring out the original expression. This is equal, the original expression is equal to this huge expression here with the terms factored out. More examples here, and let's try to write as a cubed minus b cubed. Let's see, we can write as x, y cubed. In this situation here, y squared, because if we have y squared cubed, this is equal to y to the 6th, right? We multiply the exponents. Y squared cubed minus 27 is 3 times 3, 9 times 3, 27. So 3 cubed is 27. 3 cubed. Okay, well, here we can factor it out as xy squared, right? This is going to be our a minus 3z. This is going to be our b multiplied by a squared xy squared x squared y to the fourth, right? When you square the whole thing, it's going to have x squared y to the fourth plus a times b. Let's write here 3z times x times y squared plus b squared. That means 9, 3 squared, z squared. Oops. And that's how we factor out, how we find the equivalent expression to this original one, using the sum or the subtraction of cubed, the sum or difference of two cubes. This concludes section 5.7, factoring by special products. Thank you for watching.